Hey everyone, welcome back. In today's video, we will be diving deep into one of the most widely used algorithms in machine learning, that is decision tree. Whether you are working on a classification or regression problem, decision tree provides an intuitive way to model complex decisions. Imagine you are trying to make a decision. Should I go outside today? Your thought process might include factors like the temperature, weather, or events planned. Similarly, decision trees split decisions into smaller and more manageable parts. Let's break down how they work. Here's what we will cover in today's video. First, what is classification and types of classification? Second, what is a decision tree? Third, key terminologies in decision tree. Terms like leaf node, root node, splitting, pruning, parent node, child node, branch, and more. Fourth, how decision tree decide where to split. Here, we will learn about entropy, Gini impurity, information gain, and how these metrics help make decisions. Fifth, building a decision tree. Step by step, using an example dataset, we will calculate entropy, Gini impurity, and choose the best split. Sixth, advantages and limitations of decision tree. Seventh, use cases and real world applications of decision tree. Eighth, we'll end by building a decision tree using Python and the scikit-learn library. So let's get started. So, firstly, what is a classification? Classification is a supervised learning technique where the goal is to categorize data into predefined classes or labels. For example, classifying emails as spam or not spam, or predicting whether a customer will buy or not buy a product. There are two main types of classification. First, binary classification. When there are only two possible outcomes, that is, yes, no, or true, false, these are binary classification. Second, multi-class classification. When there are more than two outcomes, example, classifying animals into categories like cat, dog, or bird. Decision tree can be used for both binary and multi-class classification. Now, let's talk about decision tree, one of the most intuitive algorithms used for both classification and regression tasks. A decision tree is a supervised learning algorithm. It works by splitting data into subsets based on feature values, making decisions at each node until it reaches a final outcome at a leaf node. Each node represents a feature, each branch represents a decision rule, and each leaf represents the final prediction in decision tree. The decision tree works by recursively splitting the dataset based on specific features that provide the highest information gain. The objective is to create a tree that minimizes classification error by making the data as pure as possible in each split. Let's familiarize ourselves with some important decision tree terminologies. First is root node. This is the first node in the tree representing the entire dataset. It contains the feature that best splits the data. Second is leaf node, also known as terminal node, the final node that provides the outcome, class, or value after all the splits have been made. It has no further branches. Third is splitting, the process of dividing a node into two or more subnodes based on a condition or attribute is splitting. Fourth, branch. Branch is a section of the tree that connects node representing the outcome of a split. Fifth, parent node. A node that splits into more nodes is parent node. Sixth, child node. A node resulting from a split of a parent node. Seventh, pruning. A technique to reduce the complexity of the decision tree by removing branches that have little importance or contribute to overfitting. Eighth, depth. Depth is the number of levels in the tree. A deeper tree is more complex and may lead to overfitting. So these are the building blocks that defines the tree's structure. The tree selects the best feature to split the data based on certain criteria. Two commonly used criteria are: first, Gini impurity. It measures how pure a node is. A node is pure if all its elements belong to a single class. The Gini impurity formula is 1 minus summation of probability of all the classes. Second, entropy and information gain. Entropy measures the randomness or uncertainty in the data, while information gain calculates how much entropy is reduced after splitting the data. The goal is to maximize information gain at each split. Formula is minus summation of proportion of class I multiplied by log probability of class in the dataset. Information gain IG. Its formula is given, where A is the feature and SV are the subsets resulting from splitting on feature A. Now, moving forward to make this more practical, I have created a small manageable dataset and will calculate everything step by step. Consider a small data set of customers with features like income, age, and whether they purchase a product that will be our target label. Income has three categories, that is high, medium, low. Age group has three categories, that is young, middle, and senior. Purchase is the target class that have values of yes and no. Now we want to build a decision tree that predicts whether a customer will purchase a product based on income and age group. The decision tree starts by choosing a feature that provides the most information to split the data. So we need to find out which feature should we choose as our root node. For this, first step is calculate the entropy of the root node. The entropy formula is minus P1 into log P1 minus P2 into log P, where P1 is the proportion of positive class, in this yes, and P2 is the proportion of negative class, that is no. Total instances in our example is 8, where purchase yes is 5 and purchase no is 3. So probability of yes is 5 by 8 and that of no is 3 by 8. By putting this in formula, the entropy of the root node is approximately 0.95. This represents the uncertainty or impurity in the data at the root. Second step, calculate the Gini impurity of the root node. The Gini impurity formula is 1 minus P1 square plus P2 square, where P1 and P2 are proportions of positive and negative examples respectively. Let's calculate the Gini impurity for the root node. By putting this in formula, we get the Gini impurity of the root node as 0.46875, indicating the degree of mixing between the classes, that is yes and no. Step number 3. Calculate entropy and Gini for splits. Now we'll split the data based on the features and calculate the entropy, Gini impurity and information gain for each split. Split by income. First, it has 3 instances in which purchase has 0 yes and 3 no. Income has 2 medium instances where purchase has 2 yes and 0 no. Whereas 3 low instances in which purchase has 3 yes and 1 no. Next step 3.1. Calculate entropy for each income group. Income has 3 high and all instances are no. Has 3 medium and all instances are yes, and low has 2 yes and 1 no, and has entropy of nearly 0.918. Step number 3.2. Weighted average entropy for income. Now let's calculate the weighted average entropy for the income feature having 3 high instances, 2 medium and 3 low instances. By putting in formula, we get entropy at 0.344. Step number 3.3. Information gain for income. The information gain is the reduction in entropy after a split. By putting in the formula, we get the information gain as 0.610. Step number 4. Calculate Gini impurity for split similar to entropy. We can calculate the Gini impurity for each split. For simplicity, let's focus on the most informative feature, Gini impurity for income. Gini of high is 0 as all are no. Gini of medium is also 0, all are yes, and that of low is 0.444. Then weighted average Gini for income is 0.167. Step number 5. Build the tree based on information gain. Since income provides the highest information gain of 0.610, it will be chosen as the first split. We can proceed similarly for other features like age group. Let's summarize the result and compare income and age group. In this table also you can see that income has a higher information gain than age group, both in terms of entropy and Gini impurity. Therefore, the best features to split on first is income. Now we will build our decision tree. So our decision tree looks like this. First root node is income. The first decision is based on income. The root node splits the data into three branches: high, medium, and low. Income is equals to high. The tree further splits based on age group. If the age is young, it predicts no, did not purchase. If the age is middle, it also predicts no, did not purchase. Income is equals to medium. Customers with medium income, everyone in this group purchased the product. So the tree directly predicts yes. For income is equals to low, the tree further splits based on age group. If the age is middle, it predicts yes, purchase. If the age is senior, it needs to split further. For one customer, it predicts no, did not purchase, and for another, it predicts yes, purchased. Decision processes at each node. First, income. It's chosen as the first decision features because it gives the highest information gain or reduces impurity the most. Second, age group. Used to further refine the prediction at each branch level. Third, leaf nodes. These are the final prediction where all data points within that group belong to the same class, either 0 or no. This is how the decision tree structure helps classifying whether a customer will purchase based on their income and age group. Now, why use decision tree? They offer several advantages. First, interpretability. Decision trees are easy to visualize and understand. Even non-technical stakeholders can follow the logic of the tree. Second, no need for feature scaling. Unlike many other algorithms, decision trees do not require normalization or standardization of features. Third, handles both categorical and numerical data. Decision trees can work with a mix of numerical and categorical features. Fourth, automatic feature selection. The algorithm automatically selects the most important features through the splitting process. But decision trees also have some drawbacks. First, overfitting. Trees can become overly complex, especially when they are deep, capturing noise in the training data and performing poorly on new data. Second, instability. Small changes in the data can result in completely different tree. Third, bias toward features with many categories. Features with more unique values like zip code or IDs can dominate the tree. Now let's see use cases of decision tree. First, marketing. Customer segmentation, where the tree helps to classify customers based on their buying behavior. Second, healthcare. Predicting whether a patient has a particular disease based on symptoms and medical history. Third, finance. Credit risk analysis, where the decision tree predicts whether a loan applicant will default or not. Now that we understand what a decision tree is and how it works, let's walk through the practical implementation of building a decision tree model step by step. We'll use a simple data set to demonstrate the complete workflow, from preparing the data to training and then evaluating the model. So, here are the 5 key steps we will follow for our implementation. Step number 1, importing necessary libraries. Step number 2, prepare the dataset. Step number 3, splitting the data into training and testing sets. Step number 4, train the decision tree model. And step number 5, evaluating the model and make prediction. So let's open Colab and we will do it together. So for this, I'm using Iris dataset. First, we will import all the libraries that we will require. skleon. Now run this. Okay, it's done. Now we are going to load our data set. Now defining X and Y, where X will be our feature. In this data set, we have X as measurement of flowers. So iris.data, and Y is our target. It tells about species of flower. Okay, it's done. Now we'll split our data set into training and testing. Here I'm splitting as 80% of training and 20% as testing. So test size is equals to 0.2. Run this. Okay, now we will create instance of decision tree classifier. CLF is equals to. We are using this decision tree classifier. Criteria we are giving as entropy to measure our information gain. Entropy. Now fit this into our model. Run this. Okay, it's done. Now we'll start predicting. Y prior. On our test data. Run this. It's done. Now we will evaluate our model by calculating accuracy. And printing the accuracy. And this. Okay, here you has okay. Here you can see our accuracy is 100%. In our case, accuracy is 100% because our data set is quite small, that is 150 samples. So maybe our model gets the pattern and predicts perfectly. Now let's visualize decision tree. Run this. So here you can see decision tree in visualized manner. It has written all the entropy that it calculated in each split. You can check it out by creating your own decision tree. Okay, to summarize, decision trees are a powerful and intuitive machine learning algorithms. They are easy to interpret, can handle various data types, and automatically perform feature selection. However, they do come with challenges like overfitting and instability. By using techniques like pruning and combining them with ensemble methods like random forest, we can significantly improve the performance. So, thanks for watching. If you found this video helpful, do like, share, and subscribe to the channel for more search data science and machine learning related content. I will see you in the next video.